Hello, my dear students. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for GATE and ESE preparation. Today, in this particular video of Daily Dose, we will be discussing a very interesting question from velocity analysis from the subject of theory of machine. And why this question is so important, because it is actually taking the concept of engineering mechanics and theory of machine clubbed together. So let us see what is this question all about, and let us understand the concept by using this question. So the question is something like this. A rod AB shown in the figure, this is a rod AB which is shown in the figure, is pinned at point B, right, and rests on a 8 centimeter radius wheel. The wheel rolls without slipping with an angular velocity of 12 radian per second. So they have given the value of omega as 12 radian per second in the clockwise direction, and the angular acceleration is 3 radian per second square in the anti-clockwise direction. That means it's an example of a retardation case. So the question is, what is the sliding velocity at the point of contact A? What is the velocity at this point? Now, always we have a tendency that whenever we are talking about rolling without slipping, that means pure rolling motion, we always say at the point of contact, it is always zero. It's not like this. This is we are talking about for the roller. The point of contact will be this, and its I center will be I. So the velocity at the point of contact at the bottom, because the roller is rolling at the flat surface. Okay, so at this point, at point I, will be having the zero velocity, and that will be the I center of this particular roller. So if I want to calculate any velocity on the circumference of the roller, we know a very interesting concept. So for having more clarity, I've already drawn the diagram so that we can have a discussion over here. So we need to calculate what is the velocity at point A. So the velocity at point A will be, join this point A with the I center. Then VA will be equal to AI, the distance AI into omega, right? Because in pure rolling motion, we are having a combination of translatory as well as a rotational motion. So if I want to calculate velocity at any point on the circumference of the roller, just join that point with the I center, right? Multiply with the angular velocity, that will be the velocity of VA. Now in the question, they're asking what is the sliding velocity at the point of contact A. So we need to calculate what is the sliding velocity at point A. So for that, if I try to resolve these forces, if I say this is VA cos phi, VA cos phi, and this is your VA sin phi, sin phi. So VA cos phi, the component VA cos phi will be the we can say the sliding velocity at the point of contact. So we can simply say the velocity of sliding at the point of contact is nothing but VA cos phi, right? And if I want to calculate, let us suppose in future if they're going to ask you what is the angular velocity of this AB link, if they're going to ask you what is the angular velocity of this AB link, because if I say this is your VA velocity, right? If I take the component VA cos phi and VA sin phi, so VA sin phi will be responsible for the angular velocity of this link AB into the distance AB. Okay, so if they're asking you what is the angular velocity of link AB, you can easily calculate by using this formulation. But in the problem, they're asking what is the sliding velocity at the point of contact A. That will be this component, that is VA cos phi. So our challenge is, we need to first of all calculate the value of VA, then put this value over here, and also we need to calculate this value of phi. Okay, now you know that this particular angle will be 90, right? And also the radius with point A, because this is tangent, this is also 90. So if I say this angle is theta, okay, or if I say this angle is theta, then this angle will also be theta, or we can say phi is equal to theta. Theta is equal to phi. If I'm assuming this angle is theta, right? So this will be 90 minus theta, and this will be your again theta, right? So ultimately we can say theta and phi are equal. So if I take this particular triangle inside the roller, if I say this is theta, this will also be theta. This is an isosceles triangle. Okay, so we can say what is the total angle over here. So for that, if I draw a perpendicular over here, so it is making, if you see OA and this triangle, it is making a right triangle over here. So it will be angle 30. If this is 30, this is 90, this will be 60. If this is 60, this is 90. So we can say 90 plus 60 plus 2 theta is equal to 180 degree. So from here, I'm getting the theta value as 150, 30, it is 15 degree. So I'm getting this value, angle theta is equal to phi is equal to 15 degrees. So I got this first part, phi value, I've calculated. So the only challenge that we need to overcome is calculate the distance AI. So if you see this particular triangle, if you see this particular isosceles triangle, this is O, this is A, this is I, these are the two radius. So I can say AI square is equal to R square plus R square minus 2R square, 2R square into cos of 150 degree, because this complete angle will be 60 plus 90, that is 150, right? So from here I can get the value of AI is equal to 2R square, take it as common, 1 minus cos of 150 degree, right? Cos of 150 degree, right? So from here I can get the value of AI. Radius is given, the radius is given as 8 centimeter. You can convert into meter. Placing all the values, you are getting the value of AI distance is coming out to be somewhere around, I think they're asking finally centimeter only, so no need to convert our dimension from centimeter to meter. So we're getting this value of AI to be approximately 15.46 centimeter. So once we are getting the value of this AI, I can now easily calculate the velocity VA. So VA velocity will be equal to, VA is equal to AI into omega. So what is the distance AI? It is 15.46 into, what is the angular velocity? It is 12. So if you multiply 15.46 into 12, you will be getting a velocity of 185.1 centimeter per second. 185.46 centimeter per second. So once we are getting the value of VA, now we'll be easily able to calculate the value of sliding velocity. The sliding velocity at the point of contact is equal to VA into cos phi. Okay, so VA is 185.46 into cos of 15 degree. Solving it, you'll be getting exactly 179, approximately 179 centimeter per second. Okay, 179 point, I think 1 centimeter per second. So by this way, I'm able to calculate the sliding velocity at the point of contact is coming out to be 179.1 centimeter per second. Very interesting problem. It is actually checking your concept of rolling as well as the theory of machine concept. I hope so you all enjoyed, and you can do one thing. You can take one question as an homework and you can tell me what will be the angular velocity of this link AB. You can tell me in the comment section by watching this concept, and please try to understand, because these type of question is being frequently repeated in the GATE examination. Okay, so this is all from my side. A very good question from the velocity analysis. So this is Sooraj Gopi signing off. I hope you all enjoyed. Thank you guys for watching this video, and if you want to have more such awesome videos, do subscribe to this channel, like this video, and stay connected with BYJU'S Exam Prep. Thank you guys. Take care. Stay safe.